NASA extends the operation of the space station to 2030. After that, it'll be crash-landed in the South Pacific Ocean. Earth has another groupie on its tail, a Trojan Asteroid sharing our orbit, the second to be discovered. And the first lonely black hole has been found. That's hanging out with no one. It's the 6th week of 2022, and Dr. Brad's back.
This is Trekzone's Talkin Science.
A very warm welcome to 2022 on Trekzone. Brad, thanks for beaming back in for another season, my friend.
How's it going?
Really well, my friend, really well. What an incredible year it's been so far. 5 weeks into it, 6 weeks into it now, and science never sleeps. We talked about that a couple of years ago. Very much the case. You're a busy boy at the moment.
Yeah, something like that. There's always something happening in 2022 already.
Exactly. Well, we're doing things a little different this year. More on that later. But first, let's get straight into the stories that are making the show for us. Brad, NASA's given a 6-year lifeline to the International Space Station.
Yeah, it's exciting that there is at least clarity about what's going to happen. It'll be unceremoniously, but at least there's clarity now of what's going to happen.
And this, as you say, clarity, it gives teams working on the station certainty. There's been a dark cloud hanging over what's going to be happening with the space station. Are private entities going to take it over? Is NASA going to crash it back to Earth? Are they going to extend the funding for 6 years? Turns out that they have. We still don't have Russia's word on that, whether they're going to, they're one of the key principal partners in this. We don't know whether they're going to be joining in on the 6-year extension, but definitely with NASA, with that funding certainty now for 6 years, people can sort of continue to pay their mortgages and get stuff done up there in low Earth orbit.
Yeah, I think, as you said, one of the critical parts is what's going to happen and what was always the plan. And 2024 was always this time because the U.S. and Russia said, hey, we're looking at going back to the moon and we're going to invest in that. And everyone kind of understood, but there was this clear gap between that and when the private companies can build their own space stations and take over. And there was a real worry there would be this lack of access and lack of research up there. So giving it until 2030, as you said, has that clarity. People can plan, but there's also now a clear transition plan of groups like Blue Origin, Axiom Space, and their plans of their own space stations to take over, and NASA to buy rights and shares, much like they do with SpaceX. And so I think this is the key. None of it is necessarily surprising what's been said, but it's good everyone has agreed, and more importantly, Congress and the administration has agreed that this is the way to go with NASA.
We've certainly been treated to some amazing views and awesome discoveries over the lifetime of the station, Brad. First started construction in 1998. We've watched the shuttles go up, build her from the ground up, if you'll pardon the pun. We've had so much else happen there as well. Differences a year in space makes to the body, spectacular views of Earth. I can't imagine what we're going to be experiencing from Gateway, the next NASA space station from around the moon. And as you say, these private companies are going to be building space stations in low Earth orbit. So we're certainly not done with inhabiting low Earth orbit, but in terms of government involvement, much like rockets, rocket launches now are very much a private affair.
And I think people would be surprised if actually how many private companies already have a say on the International Space Station. Multiple groups have their own platforms. So these are parts of the space station that you send experiments, in particular telescopes or outward-facing experiments that you plug into and get a share or time on. A lot of those are already managed by private companies. So this isn't groundbreaking necessarily. This isn't a fundamental change in the way anything's done. It is that continual gradual process, as you said, with rockets, building up, investing. And the fact is, no one group, as we've talked about before, no matter who that group is, can do everything financially, time-wise, skill-wise, and given how much effort is going to be put around the moon and how exciting that is, you don't want that to detract from activity around low Earth orbit. Or you don't want activity around low Earth orbit to be kind of second fiddle in terms of funding and effort. But that is not going to be the case with these private companies who have their own visions, their own missions, their own ideas. And it also eventually will just mean cheaper access, both for NASA instead of maintaining this whole thing, and also other consumers and other companies as well. Again, as we've seen with rockets, the private industry allows for the technology to be more refined and therefore a cheaper, easier, and more flexible way than what we've had in the past. And so I think a lot of people are looking forward to this future. It's not the end. It's actually a great transition and a great plan that people have pointed to that we've needed for a long time.
What I love about this, the sort of way that it's going in my mind, is that NASA and the other government agencies are showing the way forward and then handing it over to private companies. We saw that, with the Saturn rockets. Let's go back to the 60s, the Saturn rockets doing that, and now you've got Falcon 9 Heavy. You've got the China agency doing that as well, and all those sort of things. Now we've done it with the space stations. We've shown NASA's shown over the 40 years how that can be done in low Earth orbit. Private companies are taking that over. Now the next step, they're going to show us how it's done around the moon and onto Mars, eventually leading to that privatization. And not some of those initial privatization Martian missions which have been out there, which have only shown one way to get there and not the other way back. There's Mars 1, I think it was.
Yeah.
But, we're going to see that forward with NASA and certainly things to come in the future as well.
Well, and your point is spot on, because this is something that people don't really realize or don't think about is, research is best done when you are doing the research and trying to understand the answer, and you're trying to understand the experiment, and you're trying to understand the results and proving it can work. Research, no matter what it is, space or physics, biology, is best done when, it's sticky tape and you're kind of wondering if this is going to work or not. And that's what NASA is. This is what NASA fundamentally is. It is a research organization. It is not a commercial operation organization. And I think that's the point that sometimes gets lost, is that it is all about getting fundamental research done. And once the answer is known, and once we know how to do it, hand it over to private industries who can then better refine it, that they don't need the answer. They now need to improve the answer, right? And this is this beautiful relationship that is being struck better and better all the time between research and industry, in space in particular. And no matter whether it's NASA or whether it's here in Australia, there's this lot of effort of how do we take what we do in the lab and then commercialize or improve it. And it's getting easier to do, it's getting better to do, and it's getting both because there's now actually surprisingly more companies that are willing to take it on board instead of just a few. And so the fact that you have this proliferation of companies who are willing to understand, take risk, and be specialists in these areas and then own those areas, that is the true remarkable thing that we've seen here. We've never would have had a company who just want to focus on activity in space, which is what Axiom Space is all about. That really wasn't something talked about 10 years ago, but it is. And this is now the world that we can take advantage of, as you said, and we'll repeat it with the moon. So then we can focus on Mars.
Exactly right. Looking forward to the years ahead, even though they are the end of the space station. Well, Brad, let's move on. Research has shown that the Earth trails an asteroid barely a kilometre across in its orbit around the sun. We're sharing the orbit, is what I'm trying to say. Only the second such body to have ever been spotted, Brad.
Yeah, this is what we call a Trojan asteroid, and these are asteroids that end up locked at a very specific point in space that are relatively stable. So we call these Lagrange points. It's been famous because that's where the James Webb Space Telescope has been headed to, one of these called L2, so further out. But if you go onto the sides, where the gravity between Earth and the sun, and even the moon in some cases, can be equal, things become very stable. So the gravity tugging on it from the sun inward and the Earth outward essentially means that these asteroids can relatively park there. And Jupiter, because of its massive gravity and its size and a bit of how it was formed, has huge groups of Trojan asteroids. This is only Earth's second, so it's not entirely surprising that we found one, but it is unique to find yet another one. in one of these orbits.
Now, it's called 2020 XL5, meaning it was first spotted in 2020, in December, more specifically from Hawaii. But it took another year and a bit to make follow-up observations from Chile to establish exactly what it was. As we now know, it is a Trojan asteroid, Brad.
That's right. And so in one of these pockets, so this was in specifically L4 that it was found, the Lagrange Point 4. There's 5 of them. Importantly, it's actually kind of hard to find. I think this is something that we don't necessarily appreciate because it's kind of like it's always at the exact same spot relative to Earth in the sky. So it's not that it's a planet or a star going at a different motion relative to Earth. It pretty much is going at the same motion in the same direction in the same way for thousands of years. So they're actually relatively hard to find around Earth. It's like it's in your blind spot and staying in your blind spot while driving. You have to put a lot of effort there to find it. And because it's of its spot, it is always in a very unique position relative to the sun because the sun has to balance its gravity out with the Earth, which means it just makes it quite tricky to find these things. And so the fact that they found a second one, obviously, people wonder how many of these do we have and whether they are permanent fixtures where either always going to be there, they're only there for a little bit, or some have even come and gone that we've completely missed.
And as you mentioned, Lagrange points, they've certainly come up with the James Webb Telescope. They've been around for a little while. We've known about them. This asteroid is stuck up there as well. The research is currently suggesting that it's going to be there for a few thousand years. It's cosmologically, that's a short time. That's just a little bit of a trip in the neighborhood, but certainly a few lifetimes for us.
Yeah, I think the thing is, more importantly, it probably means that it was some sort of object that was captured or came into orbit and then stuck there. When we look at the Trojan asteroids around Jupiter, they do appear to be things that form physically there and are the pretty much remnants of the solar system. As we talked about last year when the Lucy mission was sent, is going to go visit these asteroids to understand more of what it's about. So, the question is, does Earth have many of them? If this one isn't stable, as we say, because it is not fully perfectly in L4, Lagrange 4, that means that it will be kicked out. So it probably didn't form there. Are there others that have formed there that, again, we have missed? Because something a kilometer wide at this very peculiar orbit, which is still relatively far away, they're hard to find. We have a hard enough time finding the big ones around Jupiter, which we can always see, essentially. So something like this is tricky.
Well, lastly this week, Brad, excuse me, an isolated stellar mass black hole has been detected floating through interstellar space for the first time.
Oh, when this paper popped out the other week, we all got excited. And it was one of those where it wasn't subject to a huge press release or anything like that. Which is quite surprising, but it's because of how important this object is. So when we say a rogue or an isolated black hole, in particular what we call a stellar mass black hole, one that is the mass from a single or two stars that have exploded, we don't really find them by themselves. They're in star clusters or galaxies or groups. They're not just essentially by themselves. They're not really free floating by themselves. And this is really important because when we think about how many black holes there are, what ideas they could be, actually how they interact with the universe, they don't really just hang out in the middle of nothingness, so to speak, in space. It's still in the Milky Way, but it's kind of, it's just there. And we have long thought they could exist, but it was, how could we ever find something when there's nothing else to find around it? Because that's actually the real trick. And, how many are they? They've been proposed for solutions from things like to dark matter to all sorts of different options. And so the fact that we found that first one really was exciting when it was announced the other week.
Well, it's thanks to Hubble. Astronomers peered 5,000 light years away in the direction of the Milky Way's bulge. That sounds a little bit wrong, but it's not. The Milky Way's bulge in the center of the galaxy. What's the key takeaway from this discovery, Brad?
So one of the things here is when we quantify both how what we call stellar mass black holes are formed, that is the collapse of a massive, massive single star into itself, Well, we know how those big stars form. They form in clusters, they form in molecular clouds where lots of these stars are formed. So they're formed near other things, not necessarily right next to each other, but in the neighborhood. And we don't really know when they're formed. We don't really know the mass ranges that forms directly these black holes rather than forming a neutron star or something else. And we don't have a clear understanding of how many they are. So it's kind of like we know it happens because we see them. We know that they create these masses and these ranges, but we don't know the full scale. We don't know the full parameters. We don't know the full story. And so by finding this rogue one, well, it tells us a little bit about both what kind of stars can form these black holes, how many can be there that we're just completely missing, because the only way to find these things is to look for what we call lensing events, where an object like a star passes in front of the black hole or behind the black hole, and the black hole magnifies that star and creates this huge magnifying effect. And this technique is well known, but you only use it when there's other nearby stars because you need something for it to magnify. It's really hard to find something to magnify when there's nothing else to magnify. And this one just happened by chance in a very isolated spot of the Milky Way. So then it really starts to bump up the idea that there actually are more of these numbers out there, way more than what they could have been previously.
8 years in the making for this discovery, Brad, proving the incredible lengths one has to go to in your field of astrophysics to find objects in the universe that don't want to be found.
Yeah, and I think this is the amazing thing is when they first got a glimpse with the Ogle telescope, I think back in 2011 it was, when they started to see this weird event. And so the Ogle telescope is led by a Polish group in Chile that looks for lensing events in particular and all sorts of things in the Magellanic Clouds or neighboring galaxies. And when they found this really weird star, they thought, well, if it is what they think it is, it would create another lensing event. But it will take a few years to get to that star. And I think this is the sort of thing that we sometimes don't appreciate in a lot of these discoveries, that even if you get the inkling or discovery, you have a lot of planning. You have to propose with the telescope. You have to plan it all out in advance. You have to get the data. You have to, and it wasn't just Hubble. They had a massive ground-based effort that because there was this very short window this event was going to happen, anyone who had a telescope was asked to say, hey, can you observe it? But it needed the right style of telescope. It needed to be in the right location. It couldn't be too small. It couldn't also be too big, surprisingly, because it's relatively bright. So it just would have saturated. But they also needed the whole thing observed, and you needed it all around the world. And because of the Earth spinning cursed in the sun, meant you couldn't just use one spot because we would get into the day. This was a huge effort and campaign to get this one single object that may have just been a flop. And these are the efforts that people, as you say, go through to get this data on these remarkable things. And I think that's why so many people are excited, because it turned out to be what we thought. Something that we've long thought could exist, just never seen. And the great strategy and effort they put in to get it.
I love when these stories come up, Brad, because you're so excited, you're so engaged with it, and it makes us engaged with it as well. It is a very fascinating discovery, I think.
It is, because this is really true, right? It's that backstory that we sometimes don't appreciate has to go in. The fact is, you have to coordinate 30 different people at in a short hours of window. That's hard in any job, let alone something like this, let alone making sure the weather cooperates, if anything.
Well, exactly right. Well, Brad, a change for Talkin Science this year. You're going to be on the first Tuesday of every month to give us a recap of the top stories, while I fill the other 3 Tuesdays of each month with a wrap of the latest in science and space. We'll still feature the movers and shakers of this awesome field, but as part of a Trekzone conversation, and if they're anything like you, they're going to be very fun podcasts to have as well. People get very, very passionate about their field, which is incredible when I look at it, because it's numbers and dots on a piece of paper, but you guys make it so much more engaging, and I think it's your excitement, your enthusiasm that comes through as well. There is plenty to look forward to this year, Brad. I cannot wait to dive into the third season of Talkin Science with you. Thanks for beaming in. We'll chat to you in a couple of weeks.
Thanks.